Okay, yeah, it's working. Like, la la la. Probably hear music in the background because I'm gonna do this in silent. Actually, no, no, sure. Um, this one, no, this one. Can I add images? No, I can't. Okay, well, I'm just gonna write it. Um, so the standard result you gave me was, if I zoom in a lot, um, sine to the 4 theta equals 1/8 cos 4 theta minus 1 over 2 cos 2 theta plus 3 over 8. All I'm going to do is quickly change this to, yeah, this works, cos 0 theta. It looks really random, but it becomes helpful in a sec. Then I need, I didn't think this through. Sure. You could just go there. F of x is very long. F of x equals sine of 4 arc sine x to the 1/5. The power doesn't really matter. Minus 8. Is there a 4? No, it's just 8. Okay. 8 sine. Oof. Arc sine x to the 1 over 5 again. Plus 12. And then this time there is no sine, wherever it would be here. It's just arc sine. This is me doing it raw, by the way. I haven't done it. But basically, you're going to start off by letting, because we don't want to be doing this the whole time. You can let, let's say you equal, what do we want it to equal? X to the 1 over 5. We can do du and stuff later. But for now, I'm focused on this. So it implies f of x is equal to sine of 4u minus 8 sine of 2u plus 12, just 12 sine of 0u. Well, cos, but I'll just leave it as u. So we have 8 sine, 2 sine. Next, we need to differentiate this. I really want to make use of this stuff up here, and I want to find a way how to use it, which is very difficult. I could attempt to get into a similar form. These should be the correct coefficients. I hope they are. If it'll let me move, that's a bad youth cabinet logo. So if I divide everything by 8, there's possibly another way to do this. So you have sine 4, that's cos 4, negative, negative. This is obviously greater. Times by 4, this is 4 times. No, that's 8 times, which is unfortunate. I need 4 times. But if you had 4 times, you have to have 3 over there. 12 over 3. 12 over 8 is 3 over 2. So the numbers are wrong, which doesn't let me do this. I'll start off, if this was an exam, I'll just differentiate like normal. So you'd have f prime of x equals, all of these can have a u prime. Oh, there we go. That would explain where everything comes from. So you can take out u prime, what do we want? Divide by 8, 16. By 32. Probably 32. If you take out 32, so you have 32 u prime, we end up with 4 over 32, which is 1 over 8 cos 4u minus just a half cos 2u plus 12 over 32. I'm going to guess it's 8 over 3. Was it? 6 over 16. 3 over, yeah, it is. From here, we can use our substitution from earlier. So I could probably make this full screen. We need to use that because we know what this is now. It's in the same form, so we can change it to 32 u prime times, what was it, sine to the 4 of u, in this case it's theta or whatever it's going to be. Yeah, so instead of theta we just have u's. And then from here we're basically just plugging things in. So since u was arc sine x to the 1 over 5, du, or du by dx rather, is you have the options of, can it stop doing that? No, okay, that's actually annoying. Thank you. You have the options to either use the formula booklet or to differentiate it from scratch. I'm just going to use the formula booklet because I have that memorized. It's going to be 1/5 x to the 1 minus 1 over 5, because I'm bad with power, so it'd be minus 4 over 5. Square root of 1 minus x squared, that'd be 1 minus that squared would be x to the 2 over 5. I hope. I'm just going along with the flow for this. Then we have this part, which would be sine to the 4. I'll use a different color to highlight what I'm actually doing. Sine to the 4 of arc sine x to the 1 over 5. And because they're inverses, this and this cancel. So you're left with x to the 1 over 5 to the 4, which equals x to the 4 over 5. And then from here we can just start combining things. I messed up one. Okay. So we've got f prime x equal to 32 u prime sine to the 4u is equal to 32 32 times, I'll do it this way, x the I could put it on the bottom. I could do 1 over 5x 4 over 5 square root minus x to the 2 over 5, because it's going to cancel anyways, times x to the 4 over 5 from before. That cancels very nicely. No, I don't want you to correct it. Okay. And then from here, we still got the 5 on the bottom, so we're left with 32 over 5 square root 1 minus x to 2/5, which I believe is what they're asking for. I'm not entirely sure. 32x, but yeah, that's what they're asking for. So overall, it's okay. Once you understand where to go with it, I guess it's okay. I think the main thing here is realizing that you have to start with differentiation and then use your substitution. Because I immediately thought, oh, if I'm here, like at this step, I was like, oh, maybe I can change it to cos somehow. And you can technically, but you won't be able to use the substitution. So they immediately want you to just sub this in or change it to something easier that you can recognize. Then differentiate and recognize the fact that when you differentiate, you get the same coefficients, or at least a multiple of the same coefficients. You can take out some factor and then you can differentiate like normal. And obviously you can use the formula booklet for this. And for this, it's just normal differentiation. And then here, they literally just want you to simplify. So it's not bad, but it's a very, you have to not be tired for this one. Like you have to be very careful with this one. Yeah, but it's a good question. Yeah, I like it.